Okay, can everybody hear me? Okay, are we all good? I think we're ready to start. So, good afternoon, everyone. I'm Neal, and this is my presentation on running your Symfony project on AWS Lambda, also known as I really love my cat. So, interestingly, when I put on Facebook that I was going to do a project, I needed people's pictures of cats, it turns out that all of my friends really, really want their pictures of their cats featured in this. And I had hundreds of photos come through. But when I'm not putting together montages of cat pictures, I work for a company called MyBuilder, the posse down in the front row here. And we have a marketplace that connects homeowners with tradespeople, with electricians and plumbers and builders, et cetera, et cetera, et cetera. And we are a growing company, and we are hiring, and we're looking for people to join us who are sort of enthusiastic and passionate, and we're looking for all ages and shapes and sizes and abilities and everything. So come and chat to us afterwards if you're looking for a new job, and if you're not looking for a new job and maybe you just want to chat to us anyway, then come and do that because we're friendly people. So back on point now, so running your Symfony project on Lambda, also known as well as coupling yourself into AWS for fun and profit. Now, why would we do that? Let's think about, well, there's two reasons why we might want to do that. Number one is fun, and the other one is profit. So the kind of evolution of a application stack on AWS might look like something like this. You start off with an EC2 box. There is a box around that wording, but it doesn't really show up on the screen, I'm afraid. So you start off with your EC2 box, and then you would put a data store on, so you've got RDS or some sort of external database. And then you think, well, Amazon give free SSL certificates, so let's do that, let's get a free SSL certificate. But you have to attach it to a load balancer on the front. And then later on, you start thinking about scaling, and you put a bunch more EC2 boxes on. But maybe you're not actually using all of those resources, and you're paying for a bunch of EC2 boxes to only use 5% at any given time. And of course, this is all costing you a bunch of red dollar signs each month. What would be nice is if we could get rid of a lot of that. So all of this stuff, obviously we need the data store still, but if we could get rid of everything else, then that's going to save us a whole bunch of money. Now, Lambda is perfect for that because Lambda is just a piece of code that runs and executes and then returns a response, and it only costs you money whilst it's doing that. You're not paying for a box 24/7 to sometimes do something. But the trouble is, Lambda and PHP from scratch is a bit of a pain in the ass. There are quite a few guides on the internet about how to achieve it, and they all say the same thing, which is you start off, you create a Lambda function, usually using JavaScript, the node runtime, and so you put a handler on there, and then you have to compile the PHP binary against the Amazon AMI, which then calls your application code, and then you return that response back to the client, let's say. The trouble is you then have to maintain it. Why? You don't really want to have to do that. And then earlier this year, I read this article from a guy called Mathieu, who's a French chap in Lyon, I believe. And this article kind of like made my jaw drop. It kind of opened my eyes as to what the amount of work that he had put into achieving something to make this all a lot easier. And this is his project, which is Bref, which is French for brief. And some of the good things about this project is that it's well documented. It runs as a plugin on top of the serverless framework, so there's a lot of the hard work is done for you. And it also runs on top of PR7. So if we go back to our kind of deployment package diagram here, what we've got is one of the features of it is that we have this standard interface to interact with our application code. And we can scale this back, and the deployment process of Bref actually also sets up an entire API gateway pipeline for you and gives you your free SSL, completely free this time. It's not going to cost you the $20 a month for a load balancer. A couple of things to remember about it, though, is that all of your logs are now put into CloudWatch. So if you get a 500 error, what normally happens is you just see in JSON server error in the browser, and you have to drill into CloudWatch to find out what's going on. And PHP is running through the command line interface, so the environment's a little bit different to what you're used to. what we're going to cover today is going to be, we're going to set up a Hello World site with Symfony 4. We're going to set up a REST API. We're going to add breadth to an existing site. We're going to think about retrofitting. We're going to do some stuff about cron jobs, and we're going to think about performance as well. So we've got a lot to get through. There are code examples, but I wouldn't worry too much about following them because it's exciting. I've got a lot of stuff to show you. So don't worry about following the code examples. We're thinking more about the concepts than the implementation today. So first of all, hello world. We are going to create a brand new Symfony project. We're going to install breadth into that as well. We're going to do some config, and we're going to check it all out and see if it works and address anything that might pop up. So starting off, we're just going to install the Symfony website skeleton. We all know what that looks like. And what I've got here is a controller which just responds and sends back the, the standard Symfony Hello World page. We're just going to send that back. So installing breadth now. And then we need to initialize breadth. And we get a nice green page to say that things are done. And it's added a couple of files for us. First one is breadth.php. That's the PSR7 interface that we've got that we showed. And the other one is serverless.yaml, which is where we're going to configure anything that we need to do as part of our application stack. The next thing to do is go back to the documentation that we've got in the project. And there's just a whole load of copy and paste. You just need to copy and paste stuff. It's super simple to get running with. So we've got kernel.php there. Was it the kernel? No, that's actually that's the breadth file example, but adapted for Symfony projects. So we go in and we take the default one and we just overwrite it using the Symfony adapter that we've taken from the docs. The next thing is a few parameters to set up in the service.yaml. At the top there, we've got the package name. We'll explore that again in a bit. We've got some includes. Now, the includes part is quite important because by default, breadth is going to try to exclude as much as possible from the artifact that it uploads. So we need to explicitly say what we want to include in our deployment package. And at the bottom, we've just got some environment variables that are going to be passed through to the Lambda. We also need to address the fact that Lambda is a read-only file system, apart from /temp. So we need to make an adjustment that our logs are going to be pushed to the temp directory when we're running in Lambda. So again, we just copy and paste that. And then we create a .breadth.yaml with some build hooks here. And the build hooks, what they do is they pre-compile the cache before the deployment takes place so that we don't have to mess about. In the request and response, our Lambda code isn't bothering to create a cache. We can just pre-cache and everything's done. And then the final thing that we need to do is just make an adjustment for Twig, because Twig, even though we've pre-compiled this cache, apparently sometimes Twig still needs to write to the file system. So we just disable Twig caching here. So we're going to press the deploy button. So it's vendor bin breadth deploy. And then we see that what happens is it downloads the PHP binary, installs our dependencies, does a bunch of stuff, uploads it. And then we get this nice kind of output. It tells us our URL to our executable. Now, if we look in the Lambda GUI here, we've got at the top, that was our package name that we had defined at the top of the serverless.yaml. And then lower down, we've got the environment variables that we had in there as well. So that's all been pushed all the way up into the Lambda system. And then if we remember that diagram we had as well of the API gateway pipeline, this is just AWS's representation of that. Again, we've got the package name on the left-hand side here, and then our actual Lambda package all the way down the other end there. So we're just going to click the URL that we've got there, and we've got an error. Okay, so let's have a look at that. Let's debug that. Remember what I said about all the logs going to CloudWatch now, so let's just drill into the logs. And we can see here we've got something about out-of-memory error. Now, I know from experience that what this actually is that I've forgotten to include the templates directory. So if I just add templates to the includes here, the next time we refresh, we get a different error. But what we've actually got, if you notice the difference between the errors, is that this one is a bit more familiar. I know that this is now hitting PHP. This isn't coming back from CloudWatch going, oh, I can't find your service. This is coming from Symfony. It's a 404. Great. I know as well in the docs that this is addressed. When we're not using an actual domain name, when we haven't yet registered a domain name against our Lambda package, we need to put a /dev prefix into our roots. So that's easily fixed. We just add /dev into the root. And then once we've deployed, we refresh again, and we've got our Symfony Hello World running on AWS Lambda, so there's not a single EC2 box there at all. We've got all of this. There is a difference, though, which you might notice, which is we don't have that path. And this is one of the examples where things are a little bit different between Lambda, the executable that we've got, and what you might be used to. But here, so again, what we've done really quickly is install Symfony, install Breath. We've configured some stuff by just copying and pasting, and we've used CloudWatch to debug. And that's all good, but the world isn't made up of the world is made up of hello worlds because people do them and forget about them, but that's useless. Let's think about what we can do in a real world kind of application. So how many people have used API Platform? It's kind of a few of you, yeah, yes, my two hands going up. So let's do something with this, because this is super, super quick to set up as well. So we are going to install API Platform. We're going to apply Breath to it. We're going to do some database stuff as well. We're going to set up a data store. And we're also going to get rid of the ugly string that we've got for the host name. So first of all, again, we're going to require the website skeleton, or the Symfony skeleton. Install API Platform. And then this is just copy and paste from the documentation about the book and the review. People familiar with API Platform will probably know about this. This is just copied verbatim from the website. And then we install Breath. And again, we initialize it. And I'm not going to go through it this time, the serverless.yaml and the breath.php. You just got to take that for granted now that we've done that each time that we go through these things. But these 4 steps here are you do them every single time. And just for this time, I'm going to add the dev prefix to the routing just so we can address that a bit later on. So now we need to set up our database connection. If we think about, again, our stack as it looks here, we're just going to put on a data store at the end. What we can do as well is wrap it inside a VPC if we want the added security of being able to control everything that comes in and out of there. But there are caveats to that which we'll address later on as well. So inside my serverless.yaml, I'm using I've set up an environment variable, and I'm using the serverless.yaml, the serverless framework format for environment variables here. And I'm setting the environment variable in my shell. That means the next time I deploy, I've got my database URL string pushed into the Lambda environment. And now we need to run some commands. We need to set up that database connection. It couldn't be simpler. It really couldn't. So we've got up the top here, the first part of it, the bin breath CLI. That tells Breath to go and invoke the Lambda remotely. So it actually means that we get access to the production environment. And then the second part of that is just the Symfony command that we want to run. So we can do that. We can create a database. And the next thing is do a naughty false update on the schema. And now the entry point to our API works. We've got, we can get an empty collection of books. And then we can try posting as well. So we can post a new book to the API. And we've got a nice response. And that's great, but I don't want to have to keep using these crappy kind of URLs that Lambda's spitting out. So imagine we've registered a domain name called kittyquotes.net, and we want to designate this as our api.kittyquotes.net hostname. All we do is in the API gateway interface, we just attach that to the system that we've just set up. We make sure that the certificate is available in the US East 1 region, because otherwise it doesn't work, and you spend a bunch of time debugging that. And we add a mapping. So we just say that anything that comes into there will go to that dev root. That means now that once we've copied the domain name and set up an alias record in root 53, we can get rid of that root prefix that we've had everywhere. Which means now we've got HTTP requests going to api.kittyquotes.net, and we've got our free SSL. We haven't got a single EC2 box there, and we've got a database connection set up, and we've got everything running on a server that only exists when that request is happening. Run through of what we've achieved here. It takes just a few minutes to get a whole bunch of stuff going. So we've installed API Platform, we've installed Breath, we've configured it, we've set up a database connection, we've started thinking about how we can make our URLs prettier. And that's great, but nobody runs only with an API. We all have a web presence, right? And as part of that's how we do business. So imagine if we've got an actual website called Kitty Quotes, as some of us do, and we've got CSS, and we've got JavaScript, and we've got images. We've got an admin system as well that you can log in and see your cats, and you can upload new images using this uploading bundle. If we want to apply Breath to that, there's a bunch of stuff that we need to do. There's things we need to think about. So we need to move the assets to a CDN. We need to think about the session storage on the website, and we need to think about how we're going to upload images. So the first thing to do is install Breath again and initialize it. And again, those same 4 steps we go through. So we create the we alter the logs directory in the kernel, and we add our PSR7 adapter, et cetera, et cetera. Trouble is, when we go to the website now, we get 500. But again, we're seeing this from PHP. We know that it's hitting PHP because it's kind of familiar to us, this format. We drill into the logs, and we see that it's complaining that I've forgotten to add manifest.json. So I'm just going to go into the YAML and add that to the includes again. And this time, when I go to the site, you can see it's there. It's working. It's not very pretty. There's work to be done, but it works. So let's think now about the assets. We're going to put them on a CDN. Let's get it looking better first of all. Luckily enough, the Symfony documentation makes it super easy to just copy and paste. So I'm just going to copy that, paste it into my webpack.config.js, and I'm using an environment variable yet again just to make sure that I don't have to keep typing the same thing. This time now, because I don't want to have to keep manually uploading the assets to the CDN each time that I do a deployment, I'm going to use a plugin that I found for the serverless framework called Serverless S3 Assets. It was the first one that I found. There may well be others, but this one seems to work OK. So I install that with npm. And I'm just going to configure the bucket. Again, using that environment variable, I'm configuring a bucket that I want the assets to go to. Again, using the serverless format for environment variables here. And then because I know that the web browser is going to be making cross-origin requests, I need to just configure some cause stuff on there as well, just to allow some getting to that. And the next thing is, in my build hooks, I want to package up everything. I need to run yarn encore prod to package the assets before they get uploaded to the CDN. But there is one caveat, which at the moment we have a bug in the package where symlinks are followed, but the target isn't actually brought into the deployment package. So I need to link yarn first, also the Symfony package for Webpack. I need to link that first to hard link everything in. We're working on that, though. So now when I deploy, you can see that it's actually uploading the assets as well at the same time. So that's taken a whole load of headache out of this for me. And then if I go into my S3 console, I can see that everything that's in the public directory is now there. So I've got my vendor assets, and I've got my build assets, and I've got my existing uploads folder is all there. Now when I refresh the page, I've got all your milk are belong to us, and I've got my CSS and I've got my JavaScripts there. But the admin panel is still missing something. Again, that's super easy to fix. It's all so well documented. All I need to do is put in a base path and point that to the CDN. It means when I refresh, I've got easy admin running, with all of its assets deployed, so it's served from the CDN as well. But at some point, what's going to happen is you're going to be clicking around and you get kicked out. And the reason behind that being is that in Symfony by default, the sessions are held in local file storage just here. It means on any subsequent request, you could get a different container, and obviously your session isn't going to be the same as it was on the previous container. So what we need to do is move the session storage to the database. Again, we can just copy and paste a bunch of stuff here. So we can copy the config for services.yaml and for the framework.yaml. And of course, we need to create a database migration to hold the sessions here. So we just copy and paste that into a migration file. And then we need to run the migration. So we're going to use that CLI script again, pass in the migrations migrate command, and it breaks. But we get quite a clear message here. It wants me to include composer.lock. So I add that into my serverless configuration, into the includes. This time when I run it, I get my migration run, and everybody's happy. So now I want to know where my images are. Again, thinking about the stack that we have, we want to make sure that all of the images are always served from that CDN that we've created, so from that file store. So the original value in, which file was that? Sorry, that was in parameters.yaml. So I've got a parameter in there that has a local path to the file, to the uploads directory. I'm just going to point that to the CDN. It means when I refresh, I've got my cat images. But the front end is still missing something. And again, that's really, really easy to fix. We just create a global twig variable pointing to the CDN, and we update the template on the front to use that variable instead, and we've got pretty kitties. But uploading new images is something we need to address here. So we have multipart form support in Bref, but it's kind of tricky to get it working with any kind of meaningful uploads. So my advice is not to bother doing it and to use Presign URLs instead. So does anybody know what Presign URLs are? Put your hands up if you use Presign URLs. One or two of you. OK, we'll go through it now. Presign URLs is basically your client, so your web browser says to your server, I want a Presign URL. And the web server says to S3, give me a Presign URL. And S3 replies with, here's a URL that's going to work one time only, because I've put an encrypted token into that URL. So it's only going to work just the once, and it's going to expire after X amount of time. And the web server sends that back to the client. And the client says to S3, at that URL, it posts to that URL, and it says, hey, here's the file you're expecting that the web server said you were going to get. And S3 says, great, fine. And in our case, then, we want the client just to tell the server, look, I've sent this file off to S3. You can update your record. And we want our server then to delete the original file so we can clean, or if there was a file existing before for that cat, just to clean things up a little bit. So now we can delete all of the uploader bundle code that was polluting our entity, so we can get rid of that, and we can get rid of that as well. And we can actually remove the uploader bundle in its entirety. Now, in my cause configuration, I need to be able to tell the bucket that we need to allow put requests in some cases. So we need to update the cause configuration to open up put requests. And we want to configure our security policy to say the uploads directory should be writable, but not the other directories. So that's an example of the policy that we need here. And we're going to write this in the YAML instead. And hat tip to my colleague Ed, who came up with this. I said, I need a policy done in service.yaml. He just went, here you are. So now, if we go into the admin panel, I can click on this first cat. When I select a new cat picture, because my hard drive is full of cat pictures, most of them my own cats. So when I select a cat picture, that's going to make that request to the server and say, give me a Presign URL. And when I save the form, that just updates the server, and we've changed the picture of the cat on the top here. And then finally, I'm going to connect my kittyquotes.net domain name to the API gateway path that we've set up. Again, using that base path mapping to dev. And now I've got www.kittyquotes.net with all of my assets and my admin system and the ability to upload and manage images. So again here, like recap, it's really, really quick and really, really easy to do this kind of stuff. So we've taken an existing site, we've installed Bref, we've put this, everything on a CDN, we've extracted the session handling and put it in the database, and we've dealt with image uploads. And that's really cool. But sometimes you need to do things like sending emails, picking stuff off of a queue, and have these repetitive tasks that we don't like to think about. And what I've got here is just an example command that's just going to print out some information. It's going to take a message parameter, and it's going to print that out, and also do a PHP info dump. So when I'm configuring a test event here, I need to pass in the CLI option, and anything afterwards is the Symfony command that I want to evoke and any parameters that go in with it. And then in my output here, I've got obviously that message that I put in, and then at the bottom is that standard output from the PHP info dump. And that means now that I can go into CloudWatch events and I can configure this to run every 5, in fact, I've had it running every 5 minutes for about the past 2 weeks. But it hasn't cost me any money because this is Lambda, and and you get like 1 million free invocations a month. So I should turn it off, but I can't be bothered. What I can do, this bit in the red here, the JSON string that you've got at the top here is what's in there, and that's just going to run every so often. And what I could do then, that message or that option could be the name of a queue that we want to pick from, or it could be the name of some emails that you want to send periodically or whatever. And we can see it gets pumped out into the CloudWatch logs. And so some example kind of ideas that you could have with that is reacting to SNS notifications. You could pick stuff off of queues. You could do things with S3 uploads. Like if you wanted to process a file that's been uploaded or something like that, you can do all of that. You can now react to these things in PHP. And it means that you've got your domain code all in one place. So you've got the same domain rules, you've got the same validations, you've got everything exists all in PHP world across the entire application stack. Let's think about sites that aren't running on Symfony 4. So imagine, because you love cats a little bit too much, you also have a website called kittyonline.net. It's there, you can look it up, which is running on Symfony 3.4. The only thing we really need to do is change that includes so that so we're sending up the app directory instead, because in Symfony 3.4, that's where everything really lives. That's all we need to do. And, oh, did I go past that? OK, I'm sorry, I've lost a slide here. But basically, that's all you need to do. And that works. I'm having trouble at the moment making it work with Symfony 2.8. There's a conflict in one of the dependencies. So 2.8 isn't really an option at the moment, but I'm kind of working on that, so we'll see what happens. But performance, you might be wondering. I'm sure you are now because the word's on the screen. When we're running PHP on Lambda, you can see that it's a lot slower than native Node.js at this end towards me of the graph. And as we increase along the x-axis, this is the amount of memory that we allocate to our function. And about here is 1 gigabyte of memory. So the more memory we allocate it, up to a gigabyte, has a drastic effect on increasing performance. But after a gigabyte of memory, then the performance is pretty standard. And it's about 20 milliseconds slower per request than just running on Node. So 20 milliseconds isn't really a lot. Personally, I think that's quite acceptable. Now, profiling the application is kind of tough. We played for about a week in trying to integrate Blackfire and New Relic, and these are throwing some issues up, namely because you need to have a daemon running as well as the agent, and we can install the agent, but getting that to talk to the daemon is a little bit tougher. So we thought, what can we do? We can use services like Datadog to monitor our invocations, they connect into to your AWS account, and they start looking at CloudWatch and figuring out what's happening and the average response times of things. So you can certainly use Datadog to find out what's going on with your application performance as a kind of stopgap until we figure out what we're going to do with actual internal tools. Now, I mentioned VPCs, about how it has a bit of an impact on performance. When we're cold booting a Lambda inside a VPC, and this is a Lambda issue, not a PHP issue, about 40% of the time of that request is spent assigning a network interface and IP addresses. So that's a huge, huge, huge performance hit that you have for that. And in fact, if you're cold booting a VPC, your requests can take up to about 11 or 13 seconds to get back to you, which is not a great thing, obviously, because nobody wants to wait 11 seconds for a website to come back to them. So the kind of answer to that we have at the moment is just make sure you keep your VPCs warm. Use cron jobs, which we showed earlier, just to ping your site every so often, just to stop Amazon from shutting that container down, or to reduce the risk of Amazon shutting the container down. So let's recap everything that we've done here. We have set up a new Hello World Symfony 4 site. We've set up an API platform site. I mean, each one has taken only a few minutes. We've converted an existing site to being able to run on top of Lambda. We've retrofitted a Symfony 3.4 site. We've talked about cron tasks, and we've talked about performance. Now, here's the crux of the matter. You can win a Nintendo Switch if you enter our competition at symfony2018.mybuilder.co.uk. And if you do that, you're going to be hitting a Lambda site that we've set up specifically for this. So, I mean, I don't think everybody here has entered, but go there now and enter the competition, because you're going to see the kind of thing that we can do with Lambda. You're going to see an actual site, this thing in user land now. And finally, please take pictures of the QR code and give me some feedback on the talk. And if anyone has questions, then please throw your hands up now, and I will try to answer them. Thank you. Thank you. Yes.
You mentioned that Brett does some warm-up as part of the process. If Lambda's going to scale up and provision more containers, is that warm-up going to happen for each container? Or?
So the question was warming up the containers. So if we have lots of requests happening, right? As far as I'm aware, like once the container's in userland, it can be sort of dealing with requests. But you can get instance scaling inside a VPC. Then maybe you'll get some issues. If you do it outside of a VPC, then you're going to get your responses back super quick anyway. The thing about Lambda is you get, by default, 1,000 concurrent invocations of your Lambda before you have to request a higher limit. So you're going to get the ability to scale to that amount anyway. Performance of that, I'm going to have to probably follow up on a blog post with that or something and try that out and then let you know. Anybody else? So has everybody learned so much that they don't need to ask questions, or does nobody really care? The latter. Okay, well, thank you very much, guys, for listening, and have a nice day.